Security of IP and wireless network. In this section, we are going to discuss the security policies adopted for IP protocol as well as the basic wireless technologies. So IP security or the IPsec, it is a set of protocols developed by Internet Engineering Task Force to support the secure exchange of packets at the IP layer, that is the security for the IP packets. This IPsec provides confidentiality, authentication and data integrity. A number of fields are appended to an IP packet when it is ready to undergo the security implementation. Authentication header AH and encapsulating security payload called ESP are the two main wire level protocols used by IPsec. They authenticate, that is, if you are using AH only authentication, and ESP means both encrypt and authentication, the data flowing over that connection. They are typically used independently, though it is possible to use them both together, but it is very uncommon that both the technologies are used together. AH means authentication only, no encryption of the IP traffic. So this serves the purpose of ensuring that we are really talking to who we think are, detecting alteration of data while in transit, and also to guard against replay attacks. So what do you mean by replay attacks or the replay attackers? They capture the data from the wire and attempt to re-inject the data back onto the wire, but at a later date. So we can see from this diagram is that when the data is received from the application layer, the data is sent to the transport layer where the data is encapsulated within the TCP packet, and we can see the TCP header. Next, the data is sent to the IP layer where it is encapsulated within the IP packet, and we can see the IP header. And to provide security in the IP layer, the IPsec protocol is used. So there are two varieties, whether ESP or AH can be used. So let us see what are the fields of AH header. So we have the next header field. This identifies the type of the protocol of the payload. So the type of the protocol for the payload is the, so for AH or for IPsec packet, this becomes the payload. So the type of the payload is IP packet itself. So it's the original packet type being encapsulated. This is how the IPsec header are linked to an IP packet. Next, the length. It defines the length in 32-bit words. We have the reserved field. This field is reserved for the future use. That means if any new options to be added to the header, this can be used. Security parameter index. This is a 32-bit identifier to identify the security association. So mainly this tag helps to discern between two traffic streams, because there might be a different encryption rules or different encryption algorithms used for the authentication as well as for encryption. So this identifies that. Sequence number, it identifies the packets so that the anti-replay can be avoided. Anti-replay means sending the same packet. So same packet means the packets which are received will have the same sequence number. Authentication data, this is the integrity check value which is calculated over the entire packet. So checksum value we can say, or a integrity check value, is basically used to determine whether the packet is altered or not. So this integrity check value is calculated over the entire packet, which also includes the headers. So these are the fields of your AH header. So authentication can be done with the help of MD5 algorithm or SHA-1 algorithm. So this field might have the message digest or the hash value. So it is used for the authentication purpose. The encapsulating service payload provides data confidentiality and also provides data origin authentication. This is an option. Authentication, data integrity checking and replay protection. With ESP, both communicating systems use a shared key, that is a single key for encryption and decryption, or public key for both encryption and decryption. Public key uses different keys for encryption and decryption. For the data they exchange, padding is provided to allow block-oriented encryption algorithms a room for multiples of their block size, because the encryption algorithm requires the data to be of certain block size. And we can see in the ESP header, let me show with the pointer. We can see the ESP header, the payload data, it is of variable length, but the encryption algorithm requires the payload or the data block to have the certain block size. So to meet that requirement, the additional bytes will be padded. So here we specify the additional bytes to be padded, and this field will contain the pad length, that is the number of bytes padded. So as we know, the next header field, it specifies the type of the payload. So we know the type of the payload will be the IP packet. Authentication is only for the ESP header, and for the encrypted payload, it does not cover the full packet. And we have this authentication data or this field. So this field, let me show, authentication data, this provides the integrity check value, and we can see here the authentication is only for the ESP header and the encrypted payload. It may not cover the entire packet. So encryption is for your the payload, and this is your ESP header, so which will encapsulate the IP packet, and these are the additional, or these are the fields of your ESP header. So security index, which specifies the security association, that is the type of the encryption algorithm used. Such information is denoted by the security index. Sequence number will identify a certain packet, and these are the other fields which we have already learned. IPsec provides enhanced security features such as better encryption algorithm and more comprehensive authentication. It requires both sender and receiver exchange the public encryption keys. It has two modes, tunnel mode and the transport mode. Tunnel mode will encrypt the header and payload of the each packet. Actually, the tunnel mode creates a new IP header and uses it as the outermost IP header of the datagram, followed by the ESP header and then the original datagram. So original datagram means it will contain the IP header and the original payload. The ESP trailer and the optional authentication data are appended to the payload. So in ESP, authentication is optional. So ESP trailer and optional authentication will be appended to the payload. When we use encryption, when you use both encryption and authentication, the ESP will completely protect the original datagram, because it is now the payload data for the new ESP packet. So, but ESP, however, does not protect the new IP header. So, we can see in this diagram. So, this is the ESP payload, we can say. So, it encapsulates the IP header and the TCP header, and as we know, the data is encrypted, as well as it will have the authentication information, and it will also have the ESP trail. So this entire packet is again encapsulated with the new IP header. So we can see here tunnel mode creates a new IP header and it uses it as the outermost IP header of the datagram. So now we can say that the IP header, the new IP header is not protected. It is not protected by the ESP. We have one more mode, that is the transport mode. So it encrypts only the payload. Since transport mode does not authenticate or encrypt the IP header, it does encryption only for the payload and it does not have authentication. So it might expose the addressing information to the potential attackers because the header is not encrypted. So the attacker can see the IP addressing. So, but we can see that the transport mode requires less processing overhead than the tunnel mode, but it does not provide much security. In tunnel mode, the new IP header, so more processing, but here processing is less, but there is no much security. And IPsec can also be used between the devices, can be used to encrypt the data between the devices, to router, security device to router, and PC to router, and PC to server. So the data can be encrypted between the security device to router, or from PC to router, and from PC to server. Security of wireless networks and IEEE 802.11. Wireless networks are vulnerable due to non-wired infrastructure. Intruders can access wireless networks by receiving radio waves carrying the packets. So in this section, we are going to describe the security features desired for IEEE 802.11 A, B and I. So wired equivalent privacy or WEP is the standard security for IEEE 802.11. So IEEE 802.11, it represents wireless local area network. So WEP offers authentication and data encryption between the host and a wireless base station using a shared secret key. Now what is a base station? A base station is a radio receiver and transmitter or transceiver, we can say, which serves as the hub of the local wireless network and may also be the gateway between the wired network and wireless network. So the working of this WEP, we can say, the host requests authentication from the base station. So first the host requests, so the base station responds. Now the host encrypts the data by using the secret key encryption. The base station decrypts the received encrypted data. If the decrypted data matches the original data sent to the host, then the host is authenticated by the base station. How data is encrypted is shown in the diagram. So first a 40-bit secret key K, which is known by both host and the base station, is created, and a 24-bit initialization field different for each frame to be used to encrypt a single frame is appended to this key. So we can see in the diagram we have a K and the initialization field, and we have this key sequence generation, which is a part of our encryption, because for encryption we require a key. And we also calculate a 4-byte CRC field, so cyclic redundancy checksum, computed for the data payload. So for the data payload, a CRC value is calculated. So now our data is nothing but the CRC and payload. So combinedly it is called as a data, so which needs to be encrypted. So the encryption algorithm produces a stream of key values. So we require stream of key values. Now the ciphertext or the encryption takes place with the help of key. So MI represents both the plain text and the CRC and the key. So we get a ith ciphertext. So now the decryption can be done with the same key, but we have this ciphertext. WEP is simple and relatively weak. So IEEE 8.11i specifies an authentication server for the base station communication. So earlier the host used to request authentication from the base station. Now you have the authentication server which does the authentication. So authentication server can serve many base stations. A new protocol called extensible authentication protocol specifies the interaction between the user and the authentication server. So for the communication between the user and authentication server, you have this protocol. So the security mechanism of IEEE 8.11i is as follows. The base station first announces its presence and the types of security services it can provide. So to the host, or to the user can request the appropriate type of and the level of encryption or authentication. So now EAP frames are used. EAP frames are encapsulated and sent over the wireless link. So it provides the interaction between the user. So EAP frames are encapsulated and sent over the wireless link. So it goes to the base station. So after decapsulation at the base station, the frames are encapsulated again, because it has to know to which particular authentication server it has to be sent. So it decapsulates and then it encapsulates so that it can forward it to the authentication server. Now it uses a protocol called Radius for the transmission. It uses UDP as the underlying protocol to the authentication server. So you can understand that from the user, first the packet goes to the base station. So their decapsulation will take place and the frame is encapsulated so that it can reach to the appropriate authentication server. So it uses a Radius protocol, which uses UDP as the underlying protocol to transmit the EAP package to the authentication server. So with EAP, the public key encryption is used. So the shared key known only to the user and the authentication server is created. Let us understand why we require firewalls. So connecting personal computers to other IT systems or the internet opens up a range of positive possibilities. That is the easy collaboration with others, combining of resources, enhanced creativity, but it also exposes users to dangers. So that is the hacking, identity theft, malware, and online fraud are common threats users could face when they expose themselves by linking their computers to a network or to the internet. So what if there was a way user could protect themselves from the very worst dangers? by having an invisible wall to filter out those threats. So it would be essential to have it. Fortunately, it already exists. That invisible wall is what is known as a firewall. So let's learn firewall in detail in next slides. Firewall is a network security device which protects the data from the outside world. That means it monitors and filters packets coming from unknown source. Thus, the hacker will not have access to penetrate through a system. So, since the hacker is not able to penetrate the system, the data present in the system is kept safe. So this firewall can be a software program or it can be a hardware device. So generally firewall is a simple router, we can say, implemented with a special program. This firewall is also called as hardware firewall. So the firewall is placed between the host of a certain network and the outside world. So you can see in this diagram, this is the firewall. We can think of it as a hardware firewall which is placed between the host of a certain network. We can see here a network. It is placed between the network and the outside world. As we know, the router which connects the a network to the outside world. So it is used to protect the network from unwanted websites. It is data coming or data is getting to the unwanted websites, and also from the potential hackers. For example, in the large company which has many small networks, then the firewall will be placed on every connection which is attached to the internet. And the companies, they use firewalls to block certain websites as well as to control the data traffic. So firewalls are of two types, that is a software firewall and the hardware. So software firewall is installed on individual computers or on servers. It will intercept every request by the network for connecting to the computer, and after this it determines if the request is valid or not. So software firewalls can also be configured for checking any suspicious outgoing requests. It's not just for incoming, it is also for the outgoing request. And you have the hardware firewalls which are incorporated into the router. So we have seen in the previous diagram where we had a hardware firewall which is incorporated into the router, that is situated between a computer and the gateway, internet gateway. Every packet is filtered by the firewall for determining the information like origin and the destination address, and this information will be compared with the rules. So there will be set of rules meant for the firewall. Suppose the packet does not satisfy the rules, then the packet will not be forwarded. That means the packet will be dropped. That's how the firewall will be able to control the traffic getting into the network.